Welcome to today's tutorial. We'll be going through a past paper for semester test 1, right? So what I'll do is I'll just close this and then go choose a random paper. Let me see which question paper we can do. What about the SSA? Let me see. Mm, mm, okay, it's pretty much the same thing here. Yeah, I think we can go through this one. Okay, so let's start. Go back to the top and then scroll down. Okay, so the first question, right? Where in memory does the following object reside? Right? It's very important to understand the difference between two things, right? The stack and the heap. So the way I'm going to demonstrate is I'm going to make an example using deer, right? So that you see what's the difference. But then the main difference is that with a stack, nope, with a stack, right? The stack, right? The memory is managed by the computer. So I like to view the stack as like your your grandparents' place, right? When you visit your grandparents, they will tell you, no, no, our child, sit down, don't do anything, don't do the chores, will do anything. What would you like to eat? So that's the nice thing about a stack. Everything is managed for you. It's like your grandparents' place. And then we have a heap, right? So the heap, you basically the memory is managed by you. So basically, responsible. You become responsible for the allocation and deallocation, right? Deallocation. So basically, you can think of the allocation and deallocation in the sense of, like, for example, you went to make yourself a meal, right? And then you put the meal on the plate, right? And then you ate. Obviously, the you left the plate dirty. You need to also clean it. So allocation is you cleaning that plate and then putting in food. Okay, cleaning the plate, right? And then after it's cleaned, that means it's ready for use, right? Then you use it, you put in the food, right? Then once you're done eating, that's where deallocation comes in place. You need to free up the memory so that the next person who's going to use the plate or the object is going to find it ready for use, clean. So I like to picture this one as like your parents' house. Your parents' house. So you do the chores. The main important thing is you do the chores. So that's the heap. So how do you know the differences between the stack and the heap? The only difference is small. It's a small difference. When you use the heap, we just need to know when the heap is used. When you use the heap, we see keywords like new and delete. Remember, I said you need to be able to allocate and deallocate. And then when you use the keyword delete, it means you are deallocating. You're deleting that memo, right? So basically you're washing the plate so that it's ready for the next person who's going to use it. So that's always important. So just know when you see new and you see delete, you're using the heap because that means we are managing the memory. We are in charge of the memory. So basically it's like your parents' house, you're in charge of your chores. So I'm gonna make this diagram. Let me give it a different name this time. Semester test 1 diagram. I might I just might. Okay, this session is gonna be a bit long, right? It's gonna roughly 2.5 hours because I have a lot, there's a lot to cover, right? Yeah, I know you'd be like, yeah, it's fine. I don't need to know this. I'll skip. Mind you, there's an exam question whereby you're supposed to implement a stack you implement a stack using pointers. If you don't understand these things, you're gonna face serious problems. So that's why I try to explain everything so that you don't have to go through that process, right? So always imagine that there's where memory is being allocated, right? So basically by memory allocated, it means that it's different areas or places where memory can be allocated. So we have two things, right? The stack and the heap. So with the stack, like I said, this is like your grandparents' place. Everything is managed for you. You don't have to do chores, right? Basically, you don't have to deallocate and allocate. Everything is done for you by the computer. So this is the stack grandparents' place, right? I'm just gonna call it grandparents, and then I'm gonna stretch it like this, and then copy, paste, and then the heap is basically your parents' place, which is basically home, right? So your parents' place, right? So, like I said, that's the only main difference. So if you forget to deallocate, you're gonna face pointer error issues, right? That's why it's also important to understand this thing at a fundamental level. Because if you understand, you know that every new keyword must be accompanied by a delete keyword because you are managing the memory. So let's make an example here. Let's say I do this, right? Let me show you something. Let me open code blocks. Let's say I'm going to write the code to show you that it actually runs. I can do that. I'll show you that it actually runs, right? We can use the keyword to initialize an integer, to allocate memory for an integer to create an integer on the stack, on the heap, I mean, using the new keyword. We can do that. So, semester test one, I'll just say code, right? Just for, and then I'm gonna go to manager, double click. Okay, this shouldn't be like this. Nope. There we go. Um, Double click and then put it back there. And then there's my code, right? So like I said, you can create an integer, right? Let me call it int heap since it's allocated on the heap. How do I know? Because it's going to return an integer, a new int. So I can do this. But then this is incorrect. You'll see that we're going to face issues when we create this. It's incorrect. Why? Because when you use the keyword new, it returns the address of where this integer that you've allocated on the heap is stored. So therefore, we're going to need to make use of pointers because pointers allow us to store addresses. So this line of code that I wrote here, this is what happens behind the scenes. This line of code int heap, it's like you're telling it to create a box, right? Some box on the stack. So basically, before I do that, right, just remember that each on the whether it's on the stack or on the heap, we can imagine that there are drawers, right? Like for example, your drawers in your room, right? And then remember, specific drawers have specific things. So that's why we have things like data types. So it's somewhat bit complex, but then it's not that hard to picture. So I'm gonna do this. And then this should be maybe brown like that, yeah. And then this can be blue, yeah, just like that. And then copy, paste here, right? So what happens is, remember, you're gonna have here. I just have one drawer, right? You see this brown thing that I have here? Imagine those are drawers, just like the drawers in your room right now. And remember, each drawer can store specific things, right? So when you use that data type, right? When you use a data type, in a way, we are saying, okay, this box that's just going to be stored in this drawer, that box can only take in only that thing. Don't try to pass in any extra things, right? So I'm going to do this and then enlarge it a bit. There we go. So what happens is when you create a variable, that variable, this one, right, int heap, what happens is you are telling the computer to create some box big enough, right? It should be big enough to fit what? An integer. An integer, we know that is 4 bytes or 32 bits. By bits, we mean binary digits. Binary digits meaning zeros and ones. So it's big enough to store that number. So I'm gonna put its name here, and then let me enlarge it a bit so that you can see. So this is int heap, right? Basically, it's like this, right? And then remember what I said, each drawer has an address. And the address that it uses, it uses what we call hexadecimal. I don't have time to explain that. You can just go to your computer science 1B foundation slides. I know you'll be like, yeah, why are you saying that? This video will be long. It might be even with 4 hours. Are you gonna watch a 4 hour video? Nope. Exactly what I thought. So I'm just gonna explain hexadecimal and then something like this, right? 2ED, just a random address, right? Just a random value. So this is hexadecimal. C++ denotes something that's hexadecimal by prefixing it with 0x, right? That's how it tells that that thing is a hexadecimal. So just imagine these addresses are different, right? I don't have time to be changing the addresses. Every single thing, basically every single thing in that you declare, right? From variables to functions, everything it resides at a specific address. You start to understand that better when you do computer science 3B, when you're doing assembly. So we have this. Let me enlarge it a bit. So this will be, let's just imagine this is the address of that shelf, right? By address, I just mean the address of where it stays. Like, for example, you stay at 36 Richmond Avenue, something like that, right? That will be your address. So each drawer, C++, not just C++, every programming language makes use of that, of those addresses. So that's why we end up using variables, because it's easier to keep track of variables and to keep track of the different addresses that will be used. So this is how the stack and the heap look, right? So I'm gonna have this int heap, and then the data type, what it does, right? It tells my computer that this box with this label, the variable name is actually the label of the box. So it tells the computer that this box with that label int heap can only accept integers. So if you try to pass things like characters or chars, you're gonna face a serious issue because it's following what you are telling it, right? Remember, the computer follows your instructions. By defining a variable, you're giving it instructions that it needs to follow. And no matter what happens, it needs to follow those instructions perfectly, right? And then this would be the data type is int, right? Like this. Okay, let me choose a different color. Okay, so this is how it looks, right? So this is what happens. It's like you have a box inside this drawer, right? This drawer here that I've selected. Imagine all of these are drawers, right? Like the drawers that you put your socks in and everything. Imagine if it was possible, like the drawer has its own specific address, just like a house. For example, when you go to visit your friend, you don't go, how would you find the house? You need to know the address, basically where the house is located, right? So you're gonna do the same thing with each shelf is going to have that address so that it knows if it happens that you want to locate this thing, it's going to use the address. So we use labels, which makes it easier to keep track of the drawers because I don't know the addresses that it's going to use. I'm not the computer. I don't know how it's going to do that. So what happens is when you say new, right, it means that we want to allocate memory on the heap. That means we want to manage our own memory and want something big enough to store an integer. So what this means is the same thing as saying create a box that's big enough to store an integer there, right? But then remember, I'm saying new int, and there won't be this variable, this box, right, will have no label because I don't care about the labels. Since I'm just going, I know that I'll definitely have access to it. I don't care about the label. So what happens is it creates that integer on the heap, right? So this will create that int on the heap, a box enough to create an int, right? Remember, when I say int, I don't mean the label. I'm just saying the data type. So let me zoom in a bit and then make it green, right? So this box is big enough to fit in an int, right? So when you, after creating that box, remember that box is stored in a specific drawer, and that specific drawer has a specific address. Then what happens is, in order for it to link to that, for that box, for this variable to link to that box, an address is returned, right? So therefore, it needs to point to, come on, an address is returned, right? So therefore, it needs to point to the address of where of which drawer has the box. So therefore, I'm gonna point to this address. So as you can see, I'm working with address. I don't work with the value. I store the address. So that's why I was saying you cannot use a normal integer, a normal variable to store this because, like I said, we need to store an address. So it's going to store that address in there. At least now we have the diagram because I'm going to use this to demonstrate how to delete two. So now we store the address. So I need to make this a pointer because what's returned by this left-hand side, right-hand side will be an address. So I have to make it a pointer. After making it a pointer, if I build and run or just build, you see the error is gone. Then I'm going to try to output C out, right? Remember, this is a pointer. So if I use it without the pointer, that star, right? Though that Watashi was star. If I use it without that star, that pointer, this pointer here, this star, that point. If I use it without, it means that I'm getting the address. So let me just build and run so that you can see. It tends to be slow. My code blocks tend to be slow. I don't know why. Maybe it's because my computer is becoming slow. Like I said, there's the address. It's exactly like in the diagram, the way I'm mentioning it. You see, it's prefixed by 0x, meaning it's a hexadecimal. So hexadecimal basically means, but then you can, for more in-depth explanation, check the slides. The CS1B foundation slides. That's where everything is explained. The hexadecimal, binary, I forgot the other one, but then yeah. So it's hexadecimal basically uses the same number of digits we use in our decimal system, which is from 1 to 9, right? From 0 to 9, I mean. Then it also, to represent numbers like 10, it starts using letters of the alphabet. So A, B, C, D, E, F, right? So if you check all these numbers in total, or these values, right, in total, there are 16. So it uses 16 numbers to represent any address, right? That's what it's going to use. There's a reason why we choose hexadecimal over binary, but then I don't want to go into too deep. So we saw the address, right? And then if I see out and then I dereference, I go to that address, int heap and line, right? I should see the value. So now what this means, right? Remember this, the video I made. This means point to this address or go to this address. So I'm gonna build and run. So this variable without the star, it just stores the address, which makes sense because what's going to be returned by allocating memory on the heap is an address. So you see, this is just a random integer. We could initialize it, give it our own integer, that's fine. But then I was just explaining this. So now, since it's accompanied by this new keyword, you have to delete whatever is at that address, right? Remember, this is the variable in its own stores the address. So you have to delete whatever's at that address. So this line of code, what it does, it goes there and then it deletes that memory, that box, right? Big enough to store, and then the shelf is empty again. It's ready for use. But then, do you see the problem here? There's still this line, this link to that shelf. We might mistakenly try to access it, but then you see there's nothing there. What's going to happen is that you're going to get what is called a segmentation fault. If you see that out on your output when you're running it by the terminal, it means that you're trying to dereference a pointer that a location that does not exist or that has been deleted, right? Or deallocated. But then by default, it's going to allow us, right? That's the problem with C++. It's going to allow us, like I said, we still have that link. So it'll think that this operation should be allowed. I should be allowed to dereference. There's a trick in order to solve that. I want us to run it first so that you see that it will still work, right? It might display a weird or it's just jam. We never know. You see, it's displaying something, right? But then it shouldn't be working at all because I deleted the memory. So what you can do is you can say int heap, right, is equals to null pointer. So you can set it to null. So null meaning it means that it points to nothing. But null under the hood is actually the integer number 0. Basically it points to 0. So it knows that if it points to 0, it points to nothing. So how does the set it to null work? So it does this. You can imagine that there's a 0 somewhere sitting in memory called null pointer. That's 0 over there. So that link here is going to be cut, destroyed, right? And then now it points to 0 or nothing. You see, it basically points to 0, nothing. Remember, 0 is empty, right? It represents nothing. So at least we've now cut that connection. So that's pretty much how these things work, right? The stack and the heap. You need to really understand it. So what I'm going to do is I'm going to go back to the question now. So I'm going to put back that box. So I'll just leave this diagram as is. Who knows, maybe we might want to go back to it. So now if I run this, right, it should crash because now I've cut the code or that link. So now it should crash. It won't show you the right error, but if you run it via the terminal, it's going to show you a segmentation fault. Since now we've set it to null pointer, it's clear that that memory no longer exists. I'm now pointing to nothing. So let me run it via the terminal, right? So let me go to documents and then code blocks project. Da, 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 da. Where did I store the oh, I think I stored it under music, right? Yeah. So there it is. I need to change that folder. So I'm gonna right click here, open the terminal as always, because I want you to see, because you never know, you might see that segmentation fault error. If I were the lecturer, I would ask that error. I would ask you, what does it mean? I'd make sure that you really understand this thing. I'll test you in many ways. So forward slashes, because this mimics or represents a different operating system. And then ls to list everything within my folder. And then now to compile everything, right? To compile my code, right? So compile my main.cpp and then send the output to a file named main. Then now it's going to create a main.exe file because I told it to name it main. Then I'm going to put a dot forward slash to execute it. So main dot forward slash main.exe. So there's the segmentation fault that I was talking about. So now it's easier for us to debug the code or to find errors Because when you see segmentation fault, we know that that means the pointer has been set to null or it's pointing to nothing. And that means we're trying to put dereference or point to a location that does not exist. That's non-existent. So that's why it's important to set it to null pointer after deleting it. Because you'll make the mistake of allocating memory that you shouldn't allocate. So let's look at this. So what I'm going to do is I'm gonna store it inside this text file, right? The answers. So I'm gonna store the answers here. I should be using Microsoft Word, right? So this is semester test 1, 2023 SSA answers, right? You'll be using Microsoft Word. I just don't have it. And I feel like it's a lot of space being occupied by that by Microsoft Office. I don't have it, so we're just gonna work with the text file. So I'll just upload the text file with the answers and then you look at it. So now we can now actually understand what's the issue here, how to solve that. So where in memory does the object reside? Pay attention to something. We use the pointer and we use new. That means it's allocated on the heap. So we're using the heap. So since I'm using the heap, therefore the answer should be A. The answer is A. And I just explained right now which one it is. How do you know whether it's a heap or the stack? So remember, it's a small letter A, meaning that's the question that I'm answering, and then the answer is that capital letter. So which of the following will release dynamically allocated memory managed by an object, a UJ image object? So which of these following ones will release, basically deallocate? So when you create a class, right? Remember, we always have a class. We're gonna have like class UJ image, right? We're gonna have class UJ image, and then we're gonna have our constructor, which is our builders, right? Remember, the constructor is the builder, the one that builds. Then we also have the destructor, which is like the demolition gang, right? The one that when their house is no longer occupied, no one's using it, they come and demolish the house because it's no longer being used. So it's like it's meant to destroy, or we call that the destructor. So those are the terms destructor. And then this is called constructor because it helps us construct or build the object. So remember, if we have a two-dimensionally or an array, that's dynamically allocated. Dynamically allocated meaning that the size was not known beforehand, right? And then so that means we were forced to use the heap memory, use the keyword new. So which one is used, or which of the following one will release the memory dynamically, right? So which one of these things will help us release the memory? It's the destructor. Because if you remember in our code, right, when you create classes, we're gonna come here and then obviously you're gonna have something like this. Okay, you shouldn't do this, right? You are allowed to do this, you can do this, but then you shouldn't write the implementation here. Remember here would have something like, let's say for example, int r is equals to 0, r is less than underscore rows, r plus plus, and then we delete that whole container for columns for the pixels. Like let's just imagine we had pixels for every single row, right? Then we delete also the container for all my rows and so forth. Then we set it to null pointer because remember what we talked about. You need to cut that connection so that you don't try to access memory that was already deleted. So obviously the answer will be UJ, the destructor for UJ image. That's going to help us deallocate this thing, right? So I'm going to go back here. So the answer is C. So for B, the answer is C. And then for C, let's look at the question. So a C++, right, has with one or more pure virtual function is called, okay, the keyword is pure here. That's the keyword, it's pure. is called an abstract class. This is true. Why is it true? So what is a pure virtual function? I remember getting a lot of questions like, what's the point of that function? You remember your practical, was it practical 4? Yeah, I think it was practical 4. Yeah, practical 4, when you had to redefine, when they told you to redefine it in other classes. Remember now that function, you could make it virtual. Virtual meaning that you force, you for those who are doing informatics, this is the same as saying overridable, right? It's the same thing by using virtual. And then if you use um basically, let me do this. Let me add to the notes here. So if you use the keyword virtual, right? In other words, you're saying the function is overridable, meaning that you can override it. You can redefine it. That's what it means. Or it means that you can redefine that function, right? Or you can just take the default implementation of your base class. That's what it means. There's multiple ways you can explain virtual, right? Then now when it becomes pure, so basically when it's virtual, it's like you can it means that you can redefine this function, but it is optional. You can redefine it, but it's optional. When you make it pure virtual, it's not optional anymore. Pure virtual is not optional anymore. Or for those doing informatics, this is what is called must override. That is the same thing in informatics. So pure virtual meaning that you must. You see here, it says you can, meaning that it's optional. Here it means that you must redefine it. And since you must redefine it, right, that means the base class doesn't have to redefine it. So how would you make a function virtual? It's simple. Let's say I have my string to ppm, right? And then there's that const at the end, and then I make it virtual. So I put the virtual keyword before the return type. Then this function would now be a normal virtual or an overridable function, right? To make it virtual, it's simple. I just say is equals to 0. Now it's pure virtual, meaning that just don't force me to write the implementation. Force my descendants to write the implementation. That's why I say here when it's pure virtual, it means that you must redefine it. It is a must. It's not something that's optional. So that means inside your base class, right? You don't have to implement this inside your .cpp. Literally, you don't. That's the beauty of pure visual. So for those who didn't understand why you had to keep redefining the same thing and why did you leave that function empty in the base class, now you know virtual. There's always a reason behind something. They teach you the problem so that you understand the solution. So this is the solution to that problem that you faced in practical 4. You would have to make it pure virtual because there shouldn't be any code. But then if there is some code in your base class, right, you can just make it virtual and say it's optional. Some descendants of mine or some derived classes or child classes will use my base classes implementation. Some will redefine, so it means that it's optional. If it's pure virtual is like this, it means that it's not optional. It's a must. It's compulsory. So just pay attention to those key differences. So they say if a class with one or more pure virtual function is called an abstract class, is that true or false? It is true. Why do we say so? Because let me show you an implementation of this thing, right? Let me show you that it won't force me to create this thing. I know some of you guys are so accustomed to header files and whatnot. If I try to implement everything here, you just get confused because you're cramming. You shouldn't be cramming. So I'm going to create a header file named DJ image. I'll put the class there for those who like to cram and get confused when you don't use header files. Like, why didn't you use a header file? It's not a must to use a header file. It's just a convenient way to do that. They can ask you that question. Just a convenient way to do what is this? Separation of concerns. So I can create a function called to ppm, right? To ppm, and then const at the end, and then it's going to be a pure virtual function. And then I'm going to say is equals to 0. Is equals to 0 just makes it pure virtual. It means that don't force me to provide the code. That's what it means. Hash include string, and then I think it's gonna need the IO stream to. No, I won't need it. Yeah, I won't. And then I'll just write the CPP file, right? uj image.cpp, and then all finish. I'll show you that you don't need to implement this. uj image.h, and then uj image, and then the constructor. Remember, all it needs is to see this. We don't have to actually implement it. uj image. This is the destructor. When it sees this, it just assumes, oh, so that's the implementation. So you see, I won't put the function here. I won't, because I told it it's pure virtual. I told it, don't ask me for code. Ask the child classes, not me. So this is now pure virtual, right? This is now pure virtual. So as you can see, think about it this way. Don't you have code that's missing here? So that we don't have code that's missing. We have code that's missing here, right? That means if there's something when the class has code missing, that means it's incomplete. Think of it as a building with floors that are incomplete, that haven't been implemented. There's windows missing. Some rooms don't have doors yet. Can you move in that room? No, you can't. Why not? Because it's incomplete. There's a door missing, there's a window missing. So therefore, you cannot create an instance of an incomplete class. And when you say it's incomplete, another term for that, we say, when it's incomplete, another term for that, we say it is abstract. It's an abstract class, meaning it's an incomplete class. So let me show you what's the issue when I try to create the object here. It might give me an error that makes sense. So I'm just going to build here. Okay, no errors. So what I want to do, this will give me a segmentation fault error here. So just keep that in mind. Segmentation fault error there. Because I'm trying to point a location that's non-existent. So let me try to instantiate a UJ image, right? Or create a UJ image object. So give me a UJ image object. You should see a funny error here. Exactly. Like Sentle always says exactly my point. Cannot declare variable of abstract type. It's incomplete. You cannot declare it. So I'm going to leave that error there because this one shows you in code blocks, right? Incomplete class. Basically, it's abstract. Since there's some things that are not implemented, therefore it makes that class abstract. So now we have an understanding of abstract and pure virtual, right? I know it kind of takes a lot to explain. I just really want you guys to understand. So one or more virtual functions is called an abstract class. They said one or more. So it means one to infinity, at least one. Even if there's one pure virtual function, obviously that means there's one function that is code that's missing. So it is indeed called an abstract class because it's incomplete. Abstract means that it's incomplete. So C, the answer is true. And then D, yeah, it's gonna be quite a chain here. Let me see something here. Okay. So I'm gonna structure it this way. So this is question one. Right, we'll do question one and then I'm gonna put, yeah, I'm just gonna make this text file easy to follow through, right? So let's look at the next thing. Which of the following problem occurs because of multiple inheritance, right? I think it's is it the no, I don't think it's, you see now, I forgot the very important thing here. Could it be, I totally forgot what they call it. Is it a slicing problem or diamond problem? I don't think, let me see, slicing. I think slicing is the solution, if I'm not mistaken. Yeah, it's called the diamond problem. Yeah, I think it's called diamond problem. So basically, what does it mean, multiple inheritance? So basically, if when you have multiple classes that inherit from the same base class, right? Or so is it like, no, it's not okay, it's not. What is the follow which of the following problem occurs because of multiple inheritance? Oh, let me try to draw this, right? Let me see if I can try to make that. Oh yeah, okay, now I'm thinking about it. It's called the diamond problem, and it's when you have like more than one base class, right? So let me show you. So you have yeah, it's starting to come back now. So let's make it, let me see. Um how can I make it, right? Okay, let me do this, right? Let me save this image first. Export as PNG, right? And then export. So I'm gonna say semester test one diagram for stack and heap, right? So there's the image. Let me see if it did save well. Yeah, perfect. So now I can just delete all of this, right? So I'm gonna do this, delete that. So we have a it's called a diamond problem because it's gonna it's gonna take the shape of a diamond. So when you have multiple, when you inherit, basically it's true, really, when you have multiple base classes that you're inheriting from. But then I want to show you how do we get the diamond shape, right? So let's say, let me think about it. What examples can I give? So mm, let me think of an example. What example can I give? Let's start with shape, right? Will shape be able to explain? You see this thing? I need an example that's a bit clearer to see. A person is a thing, right? Yeah, a person is a thing. It is a thing, but then it's an object, right? But it's a living object. And then, so I'm gonna say human, right? You are a human being. That's the base class, right? We have the human, right? And then we're gonna have the person class. Let me think. Person, you're going to have a student and a teacher. And then, let me think. If you have a parent, I'm trying to think of an example that can generate what I'm trying to make. I think they in terms of family, like viewing it in terms of a family hierarchy, right? It's easier to demonstrate. So I'm gonna select this and then let me choose a different color. Um, let's make it blue, right? So here you can think of this as like your grandfather, right? We're gonna use what you call um the family tree, right? To sort of like explain the diamond problem. So there's your grandfather, right? And then your grandfather gave birth to your parents. Yeah, this is a perfect example. At least I was able to come up with that. So your grandfather your grandfather gave birth to your parents, right? Could be, and I remember we can have, okay, let me try to, so that it doesn't allude or sort of like try to, so that you don't think like I'm saying incense is allowed, whatever, because you'd be like, how come both our parents have the same grandfather? So I'm just gonna say grandmother gave birth. Let's just assume grandfather gave birth to your father. So this would be your father. And then your grandmother gave birth to your mother, right? Which is your mother's mother and your father's father. So yeah, it's basically that. I want it to be in the shape of the diamond so that you can see it. So we have this, right? And then this should be mother. And then you were born. The little rascal, which is you, was born. So this is you, right? So this is you over here. So remember how we can denote inheritance, right? This inherits from this, right? And then let me just say, let me think. Where's the shapes again? Okay, that's the pattern. Okay, I think this isn't the one. Nope, it's not the one. Oh, it's this. Yeah, because I want to use the inheritance one. So the inheritance one is that one, right? That diamond, that rectangle. What is it? No, it's not a it's a triangle, I mean. So I'm gonna put this there and then just you don't have to do this, right? I'm just doing it for the sake of, you know, accuracy, right? And then you were born, so basically this class and that class they actually become your base classes, right? So you have more than one base class. So there it is. And then I'm gonna do this, change the arrow. Uh, then change the arrow. Yeah, so there it is, right? So I know it doesn't look like the diamond, but then this is actually how we get the diamond problem, right? When you have multiple inheritance. I know it doesn't look like a diamond, but then if you start drawing from there a line that's straight here, and then you draw a line that's straight there, and then you draw a line that's straight from there, and then you draw a line that's straight from there, you get the diamond problem. So I can demonstrate this using paint, right? Remember, I'm using the touchpad to draw. So remember what I said. I said you have grandfather here and a grandmother here who gave birth to your father and your mother, and then you were born. So you see, if I draw lines like this, right? Okay, let me not draw this line here. I just want you to see the diamond. And then this will be the inheritance, right? So basically, this is how it is. Hmm. Okay, more of a straight line, but then you get the point, right? So this will be the diamond problem, right? You see, it's in the form of a diamond like this. So we call that the diamond problem. If I wanted to, if it was possible to draw it, I could draw it like this so that you can see the diamond clearly. Why am I saying like this? Because there is fairly a parent for each of these grandparents, right? So you see, it ends up forming a diamond. So we call that the diamond problem. Simple terms, just like that. And that's how I ended up remembering it because I tried to remember that example or that that analogy, right? Um, do this. So this would be diamond problem. Yeah, so it creates the problem called the diamond problem. So this would be the second diagram that I'll just put there. So just say save as or just export. Either way is fine. And then downloads. Where did you save it? But then I saw that it saved it somewhere. That other diagram that I had. So PNG, this would be semester test one diagram for diamond, diamond problem, right? So that would be that diagram, right? So the answer would be diamond problem when you have multiple. inheritance. I think it's diamond. I hope I didn't make. I think it has to be diamond problem. If I remember very well, it has to be diamond problem. Just that there's a lot in my head. There's a lot of things that I'm juggling at the same time. Which visibility is most appropriate for variable data members that may be required in derived classes? Remember when we talked about private, public, and protected, we said public, think of it in terms like the public transport. That means the access, who has access is it's everyone in the public. Basically, it's the public is the one that has access when you use public. Private, it means that the private individual is the one who has access. And then protected means protected individuals, meaning inheritance. It's like a family secret. It's protected, it's kept safe. But then it doesn't mean that it's private to any descendants. All the descendants they know the family secret. Like for example, the family recipe on how to make the best chicken, right? That would be like a family secret. So it's protected, it's kept safe within the family. But then anyone who's outside the family, it becomes private to them because they're not part of this bloodline. So I need to write down the answer for D. It's C. And then E, like I said, we're gonna use protected, right? So the answer is going to be protected because they said which one is most appropriate, right? You could make it public, right? It's fine. But then which one is the most appropriate when they may be required in derived classes, basically in your child classes, the descendants. So that's going to be protected, which is E. So E is E. And then F. And then let's scroll down. Name the appropriate object-oriented relationship to realize the following aspects of a problem description. So a bulb holder has a bulb. And then a bulb has a filament, right? Which basically means the light generating wire. So those wires within the bulb, they're called filaments. Can the bulb light without the filament? Nope, it cannot. So there's a life cycle dependency. What is meant by life cycle dependency? So remember, this is just when you look at these notes, it's just a pure virtual function, right? What is meant by life cycle dependency? So life cycle dependence, right? It means life cycle dependence, right? Life cycle, or you can view it in terms of the lifespan of the object, right? Or like your lifespan, how long can you live, right? So there's life cycle dependency, meaning that one thing, its lifespan depends on the lifespan of the thing that it's contained in. For example, a person has a heart, right? The heart is fully functional as long as the person is still living, right? So that means there's a life cycle dependency here. The heart cannot exist without the person's existence. So when that's the case, it means that there's a life cycle dependency. So basically, this thing that's contained, right, which is the heart, and then its container, the thing that contains that thing, the person is the container, right? The thing contained is the heart. So the heart depends on the existence of person in order for it to exist, even to live. Why do I say so? Because if you have a bad diet, you're gonna kill your heart. So that means the heart has no control over its lifespan. That's exactly what it is. In simple terms, that's what it means. And then sometimes we might have no life cycle dependency, right? Sometimes there might be no life cycle dependency, meaning that one thing can exist without the other, right? So for example, yeah, okay, this is the simplest example. I don't want to overthink. So for example, Natasha has a boyfriend, right? Natasha was already existing way before she met her boyfriend, right? And her boyfriend was already existing, living his own life way before he met Natasha. I know some people will be like, well, me, I cannot live with my partner, so it's we have a life cycle dependency. No, it's not. They don't own the air. They don't own the oxygen. You can breathe air just fine without them. You still can live, right? You still can go back to your place and sleep and do your chores, whatever, and you're still existing without the person being around you. So there will be a no life cycle dependence in that case. So with this one, the life cycle dependence, it's called composition. And then the one where there's no life cycle dependence called aggregation. That's the two differences. We'll get to that. We'll also, since I've explained that, I don't have to go into it too deep when we get to EML. So now let's go back to our question. And then there's inheritance. Remember the inheritance, the descendants and whatnot. That's inheritance, right? So inheritance just means that, for example, an apple is a fruit. So basically, we could say that fruit is the parent here. Fruit is the parent. We could say that. And then apple is the child or descendant. Descendant. Or in OOP terms, it's called derived class. Derived class because this class was derived from a parent class or made from. So basically, the parent acted as like the blueprint or the starting point, right? So so since we're always going to say something is um, um, an apple is a fruit, and then all those things. So since we're going to have that thing, it's usually called a relationship. And then here we've been saying has a heart. This person is this person is Natasha is a boyfriend, things like that. So now we're going to call this one a has a relationship. For both aggregation and composition, they're both called has a relationship. So we need to look at this thing. So here sometimes you don't even need to understand the question. The only time you really need to understand the question is when it has a, because sometimes it can be composition or aggregation. Then there's the last one before I forget. There is this one called association. So association is just when it's none of the above. It's neither inheritance, composition, or aggregation. When it's neither, it just means it's associated with that. So for example, a friend you would say that there's a deep bond there, right? But then in acquaintance, right? It's like, yeah, it's not that deep. So you can view association as like that. It's like, yeah, spelling here, I'm not sure. It's like acquaint, I don't know whether acquaintance is right. It's an acquaintance, right? Or acquaintances, right? Don't think that's the right spelling, but you get the point. So it's just that. So it's like association, we're just using each other. It's not a deep relationship. It's not like I cannot exist without you, or I can still exist without you, but then we still have we have some relationship. It's like association, we have no relationship at all. It's like for for those people, it's like having a relationship with no label. Someone says, I don't like labels. So it's like having a relationship with no label. You're just associated with each other. You're just using each other in whatever way you are benefiting from the other person, but then it's not that deep, right? There's no connection there or relation, a proper connection. So a bulb holder, right? I know this, but then it's a bit tricky. This question is a bit tricky, right? A bulb holder, right? It's meant to hold a bulb. It can exist. That I agree, right? they should have chosen a different example. This can, like, technically can be both, right? Technically, but then it's like a vague example. So a bulb holder is basically the thing that holds the bulb, right? It's meant to hold the bulb. So obviously it cannot exist if the bulb does not exist, because what else would it be holding? But then in this case, we would say that, yeah, it does it like this, like what I said, the Natasha is a boyfriend example. It's still a containment, right? One thing is contained within the other, but then they can both live on their own, right? The bulb holder can be somewhere in like Pumalanga, somewhere there, right? And then the bulb can be here in Gauteng. They're living their own lives, right? Even though there is a dependency, right, on each other, but then it's like there's no life cycle dependency. Like I don't need to exist for you. I don't need to wait for you to exist in order for me to exist. I can exist on my own, even though my main purpose was to exist for you. That's why I said this example is very vague. So this one, number one, would be aggregation, right? So okay, we are now at question two. So there's no F. So we're at question two. That'll be aggregation. So here would be the end of question one. So end of question one, right? And then I'm just gonna copy this, reuse this. Since I don't wanna use what is this, Microsoft Word, I'm just gonna do it this way. And then I'm gonna have end of question two. And then A, like we said, I is going to be, so here I is going to be aggregation, because one or two of the things can exist without each other, right? So basically, it's like, yeah, you can't say that the bulb holder, in order for it to be able to hold the bulb, it needs to be able to have a bulb close by. No, you can still hold the bulb irregardless of without the existence of the bulb. So therefore, that would be aggregation. Two, a bulb has a filament, light generating wire. What's the main purpose of a bulb is to light, right? And it has a wire that lights. So basically, they cannot exist without each other. The filament wouldn't exist without the bulb, the existence of the bulb, because it needs to light the bulb, right? So therefore, there's this life cycle dependency there. The filament depends on the existence of the bulb in order for the filament to exist. And there's a strong relationship because the filament is the one that's generating the light, right? No, I didn't mean to rhyme, but yeah, it's the one that's meant to generate the light. So therefore, this would be composition. There's a life cycle dependency there. So if the bulb is not used the right way, the filament might end up failing to generate the electricity, right? The light, it might fail to generate the light. So therefore it's the life cycle or the lifespan of filament is dependent on the life cycle or the lifespan of bulb or the existence of bulb, right? So this would be composition. Composition. And then one, two, three, and then we go to the third one. This one is a bulb. So this is inheritance. Inheritance. And then B. And then question two. What is a abstract type? An abstract data type, right? Consider question two below. The class question two below. Is question two an abstract data type? That's the question. Motivate your answer by making reference to the definition of an ADT. So how would you explain an ADT, right? In the proper programming technologies, I will explain it. But then in terms of like simpler terms, right? An ADT is basically a class where you it's basically when you have the header file and the implementation kept separately. So you have the function prototype, right? Which is the class declaration is declared separately and it's also implemented separately. So if we say that in terms of the programming terms, right? Abstract data type or ADT, we say that when we have the header file and the CPP file dividing the code, right? We say that the logical properties are kept separate from the implementation details. That's the proper definition of it. So the way you'd answer it, you'd start by giving the definition. After giving the definition, then you can say that how do we know that it's an ADT? Do we see implementation? If we don't know how it implements, right? Do I know how this constructor is implemented? Nope. Do I know how this copy constructor is implemented? Nope. Do I know how this data one-dimensional arraysing or pointer is implemented? Nope. I don't know what's the size, what size will it be allocated to? I don't see any code, any implementation here. I don't see it. So basically, an ADT is when you only see the things that you usually see in the header file. Basically, you don't see any implementation. That means this person, when they're implementing this, that means they put this inside a separate file, which is the header file. We're going to say that the header file, it includes the logical properties, right? Then the CPP file, it includes the implementation details, basically the implementation of this class. That's what the CPP file will have. So if I see this, it means that, oh, this person did divide the code. They created a header file with only the logical properties or the class without implementation. Then they also created a .cpp file with the implementation details. Basically, they implemented in a separate file. Then I know, therefore, it is an ADT. So I would say yes, right? Yes, a bold yes, because the implementation details, implementation details are not exposed, or you cannot see them, right? That means it did make it an abstract data type. The logical properties were kept separate from the implementation details. Basically, we have a header file and this .cpp file. So here they're just showing you the header file. If for whatever reason, maybe here we had this one, they said is equals to new int and then square brackets with the size of the array, then that wouldn't be an ADT anymore because we can see how the array was, or this pointer was implemented. It was implemented as a one-dimensional array. When it's like this, it actually never know. It could be just one integer or multiple integers. Because like I said, look at the code. You can create a memory on the heap using a pointer, basically to store one integer. So that means I can't be sure of I don't know how it implemented it. And the constructor, do I see any code in the constructor? Nope. So there's nothing that I can say for certain that this is how this class implements its methods, right? Or its constructors. I don't see any code, any implementation. So now let's create UML. So the UML part is pretty straightforward. So when you look at the UML, right, always pay attention to how they are naming things. When you see the name of something, right, and it's not written in bold, usually that's what they're gonna do to distinguish, right? You see everything else here is written in bold. This is not written in bold, so I know it's a class. Or it starts in a capital with a capital letter, then I know that's a class. So therefore, I start creating a person. So I'm gonna close this. Did I save the diamond problem thing here? Okay, yeah, I did save it. So I can close dear. Maybe I might demonstrate, but I don't think I'm gonna need to demonstrate because the rest now is just code. I just need to explain the stacks and the queues. The stacks and the heap. Queues are when you think about queues, and think of the queue at Pick and Pay or the queue at Capitec or in month end, the queue at Capitec. I get it, it's always first come, first serve. So it's gonna use a queue uses a FIFO or FIFO, approach, which means first out, first in, first out. The first person who came in is the first person to come out of the line or of the queue. Then a stack uses a LIFO or LIFO approach, LIFO, which means last in, first out. Meaning it means the last person to go in is the first person to go out. If you want to think of a stack, think of it in terms of plates. Let's say you have 20 plates piled up together. Are you going to take the plate at the bottom or you're going to take from the top? You take from the top, right? But then the plate you're taking from the top, it was actually the last plate. But then it's actually the first one to come out. So stacks and queues, that's how you can distinguish them. And then the heap and memory, stack and heap memory, we explained that. So let's create the person class, right? Remember, when it comes to UML, do not include things they did not tell you to include. Don't start being spiritual here and putting, oh, let me put a construct, let me put a distractor. You don't have time. Time is not on your side, and they'll never mark those things either way. So why waste your time? Do not waste your time answering your own questions. Answer the questions that they told you. And I'm gonna answer one thing at a time. They said a person, so I know that I need to create a person class. So it's easy. I just know that I need to create a person class. So I'm gonna open dir and then click, tap there, and then tap here, empty space to paste that class, double click on it, and then Control V to paste the name of the class that I need to create. So on attributes, right? Attributes, these are your variables. So attributes are your variables. So when you see attributes, these are the variables or the data, right? And then attributes, how will you know these are attributes? You always look for nouns. Look for nouns everywhere. Remember grade 10, 11, 12, nouns, all those things, even before that, grade 8, grade 9. Nouns, what is a verb? All those things. And then operations. These are the functions. And it could also be constructor, right? Because remember, a constructor is it's performing an action. It's constructing. That's an action word, right? It's constructing or building, right? Or building, that's an action, right? So this would be what we just look at verbs. For example, dance. If I'm dancing, that's an action. That's movement. That's motion. So therefore, that's going to be an operation, I mean. And then attributes could be, what is your name? Age. It's just variables or nouns. That's how you find these things in the UML in the questions to create a UML. So they say it as a string name, one thing at a time. So let me create string name, new, and then what's the name of the variable? It's coincidentally called name. You could use underscores if you want. I'll use underscores, or you can just leave it as name. And then they say the data type is string. And then by default, I'll make it private unless I have to make it protected. I'll see. Remember, I'm doing one thing at a time. That's what I've seen so far. That's where I've read. I haven't read continuously and see what's next. Then now I continue and read. What's the next thing? Oh, an integer age value, right? Basically an integer age. They're telling me this variable should store age. So let me close this. It should store the age, right? So I'm gonna say underscore age. That's the name of the variable. Int. They said integer. And then I'm going to make it private by default because things in a class are private by default unless there's a reason to make them otherwise, right? So another thing is a double value indicating their weight. A double. The way they're so clear here. There's no way you can get this wrong. If you're getting this wrong, it's by choice because they are trying to make it very clear. So double, um, what is it? Not me getting lost in my train of thought. So underscore weight, and then this will be a double, and then private by default, unless I have to make it protected. When I have inheritance, right, I'll make them protected, all of them. It's not a must, right? It's just remember the main point of this semester test is so that they can see you demonstrating your understanding so far of computer science 1B. So they want to see everything. Do you know private, protected, public, Do you know all of those things? So I'll just use protected so that I can show them that I understand the reason behind protected. I'm using it because I've seen that I have inheritance. That's if we have inheritance. The name, age, and weight must be set using a constructor. They said you must set it, right? By setting it, it means that you must mutate. This is where the mutators thing comes in place. But then they said we should mutate it or change it via a constructor. That means they didn't say create mutators for it. You set it via a constructor. That's exactly what they're saying. So let's create the constructor. Remember what I said about operations. This is your functions or constructors. And if you're looking at the question paper, look at verbs. They'll they help you come up with the operations. So person, so I need to take in all those things, right? The person's name, which is going to be with data type string. So I'm gonna go to parameters there because that's where I put the parameters. If you watch the memorandum for practical 4, this part I can just fast forward, right? I can just move quickly. So age, which is going to be an integer, and then weight, which is going to be a double, and then apply. By default constructors, we're gonna make them public. And then a person's name. You see, so far I've read up until there, right? I could be wrong. Maybe they want you to put mutators. I could be wrong, but then so far what I've read up until this full stop here. So now I'm gonna read continuously to see what more information should I put into my class. A person's name, age, and weight can be accessed. Can all of them can be accessed, right? That means accessors, but only the age and weight can be modifiable afterwards. So all of them have accessors. Let's start there. You see, one thing at a time. They said a person's weight, right? Let me use a different color. So a person's name, age, weight, all of them basically, they can be accessed. That means they need to use accessors. Remember, accessors basically comes from the root word access, which just basically means I can use a synonym for that, which just basically means get. I'm accessing something, right? Mutators, right? It just comes from the word mutate, which basically, if you think about horror movies or things like that, or movies about, yeah, those movies, sci-fi movies, you can think about a mutation. It's changed, right? It changed, it evolved, right? Or we can say that this is just you changing the value, right? It changed, it mutated. Here you're just only accessing, not changing it. So keep that in mind. So I need to create accessors for all of them. So remember all my accessors, right? Remember I am getting. And then for the mutators, we say that you're setting the value. So everything that I create, which is an accessor, must be prefixed with the word get. Everything that I'm going to create, which is going to be called, which is going to meant to set or change the information, must be prefixed with the set keyword. Then I capitalize the first letter of the thing that I'm setting or getting. So for example, if I wanted to create an accessor for get name, I can't just name it like this. I capitalize the first letter of the thing that I'm getting. I'm getting name. So I'm going to call it get name. So that's what I'm going to do. So this function will be called get name. It returns a string. And then that const at the end that usually declare in the class, don't worry about it here because you can't show that here. You just show that in code. So just give it a name and the return type. That's it. So get age, that's the next one. And then it returns an integer. Apply. And then the next one is get weight, right? And then that returns a double. And then apply. And then I go back to my question. So far I've stopped here. I'm here at this comma, right? That's where I've stopped. I've created all the accessors. I've followed the instructions. You need to read one thing at a time, answer, move on to the next. Read the next thing, answer the next thing that you've read, and then move on to the next thing, one thing at a time. But only age and weight can be modifiable afterwards, right? So only they like to throw words around, right, that are different. To modify is to change, which is the same as mutating. It's the same thing. It's just different ways of phrasing it. Mutator is the same as to mutate is the same as modifying, right? Modifying, which comes from the root word modify, which just means to change. They just use synonyms for this thing. You need to know English. If you don't know it, it's unfortunate. You have to go understand English. Just watch something that is subtitles. Your English will improve if you're lazy to read a book. So only age and weight should be modifiable. So I'm gonna need to create mutators for that. So remember, mutators, we prefix them with set, right? To show that I'm setting something, followed by the thing that I'm setting. It says only age and weight, so I'm gonna set age. It's gonna return void because it's not gonna return anything, so void. Always think of void in terms of like prudence when your card is declining. You go there to Pick and Pay, they call prudence. Prudence, void, yet decline, void. Void means that nothing came through, nothing came back when they try to extract money from your bank card, right? So it's the same thing here, void. The void, nothing should be returned, nothing should come back. This function is just meant to change. So you should take in a parameter that we should use to change the age that's private. Remember, the age is private. So we need to take in an age as a parameter to set that age. So age, and then the data type for it is int. Apply, and then weight also as a mutator. So set weight, void, and then weight, that's the name of the parameter. The data type is double, and then apply. You see, I didn't put distractors or copy, don't put things they didn't tell you to put. And then they said a person can study. They even tell you it is an operation so that you don't get confused. But I can already tell that it's an operation. What is the act of studying? Are you not performing an action? You are. You are performing an action. So I need to create a study function. And it has no parameters and does not return a value, so void. It takes a no parameter, does not return anything, and we're just going to call it study so that it's easier for the assistant to mark. So the name of the function is study, it's void, it takes no parameters, apply. Done. So there's the study method there. So we are done. Now we get to the inheritance. Student is a person. So you see, now we have inheritance. So I know that I'm going to have descendants, right? Or I'm going to have derived classes based on this base class. So that means I can now since I've read that information, I now know that all of these things should be changed from private to protected. You don't have to, right? But then when the memorandum comes back, it's going to have protected because they assume you understand that protected is used when there's inheritance. And then apply, and then okay. You see, I didn't put many things. I only put the things that they told me to put. So there's my UML diagram there. Right, done. Then I'm going to create the student class, right? Student, and then attributes. So let's look at the attributes. It is a person, right? We know inheritance because it's is a relationship. Has a string representing a student number. Like I said, one thing at a time. Let's put the string, the student number. String student number. So let me do that. So with me, you don't have to create variables that are too long, right? But then I like when I'm doing my design, right? If I'm writing the design for a theory question paper, right? I write the variables in full, even if it's long, so that it's easy for the assistant to know which variable is what. So I'm gonna say underscore student number in full. And then if they said it's of type string, by default it's private because that's how classes operate. Things need to be private by default unless stated otherwise. A subject integer property, or which are both set during creation. These people, they like to trick you. So there's two things, the student number and the subject integer. So let me create the subject integer. Let me do one thing at a time, right? So let me say underscore subject. That's an integer and it's private, right? Class scope, that's static. When you this class scope option, you are saying that it's static. I don't have any static variables yet. They didn't say so. So during creation, remember what creates an object? It's a constructor. Oh, it's in the notes for the code, right? A constructor is a builder, right? It builds, right? So during the building process, basically during that time when a constructor is called, initialize them. So basically they're telling me to create a constructor that takes in these two parameters indirectly. So it's going to take in a student number and a subject. So I'm going to create that constructor, put new parameters there. Student number is the first thing. And then it's going to be of type string. Then we're going to have subject is of type int. Remember, they are set during creation. They are set when the constructor is called. So therefore, I need to create a construct. So I'm going to scroll down. They can study by incrementing the subject value and the current subject value. So this is a very tricky thing to see, right? They say they can study. Isn't study a similar keyword that we've seen somewhere? I think, yeah, they can also study here. Yeah. So as you can see, study was in the base class and it's also implemented here. So that means they want you to redefine it because the children can study by incrementing, right? So that means, gosh, if I'm being honest, that means study inside the class, inside the abstract base class is actually a pure virtual function because they didn't say what it should do. They just said it has no parameters and does not return anything. So basically, we could either be delegating or be a pure virtual function. So that means we need to redefine the study method. And remember how we create the study method, it has no parameters and does not return a value. So basically, I need to redefine it within my child class. So study and then void and then apply. And then I think that's pretty much it. Yeah, we are done with student. As you can see, I already picked it up, but as you can see, both student and staff can study in their own ways. That means they'll implement study functions in their own way, meaning that the study function needs to be redefined in the child classes or the derived classes. That's what it means. I've already picked it up here because I saw that they're saying that this child can study. And then they gave us a formula on how it studies. That means it's actually implemented in the child class. And then I'm done. So I'm done with my student class. That's it. I'm going to click apply. Okay. So this class is complete. Just leave it like that. Don't put many things that you're not supposed to put. Don't. Trust me, you'll waste unnecessary time. You don't have, I think you guys have 40 minutes, right? You don't have a lot of time. So don't waste your time doing extra things that they're not going to mark. Come on. This thing. Let me fix this. Okay. Scroll that side. There we go. So I'm gonna copy this, put a class here, double click, and then create the class. So we have the staff class, right? So basically, this basically represents like a class for representing the different types of users at UJ, right? Yeah, it even talks about it here, university. So is a person, right? Inheritance. And we'll get to the easier part later after we're done creating the classes. It has a string representing their staff number, one thing at a time. So I'm gonna go here and then create a new attribute. Student, no, staff number. which is a string. I'm writing it full so that it's easier for the person marking my class so that they can see which variable represents where did I declare the things that are being talked in the problem statement. And a research record of type research. They even told you the type, it's of type research. It's a research record of type research. You don't have to worry what is research, you don't have to worry about that. Underscore research, um, research record. Basically, this is a record structure, but then you don't have to worry about that. They told us what data type it should be. Research of type research. Private and then apply, because by default, everything in the class should be private unless stated otherwise. Representing the area of research, right? Basically, this is the lecturer's class, basically. Because a cleaner, you can't say a cleaner is doing research for UJ. That wouldn't make any sense. So the two properties are set during creation of staff object. There we see that terminology again. They are set during creation, meaning when the constructor is called. So both of these need to be taken inside a constructor, which is the staff number and research record. Hopefully I can remember it. So this is the staff constructor. So a new research record, which is of type research, and then new uh, staff number, which is similar to a student number. And then this is going to be of type string, right? String. Remember, they're set during creation, meaning when the constructor is called. When it says it is deallocated during the freeing of the memory of the object, of the staff object, right? Then you'd know that when you free memory, a destructor is called. Therefore, you have to define a destruct. They can also study by altering. I don't care about the formula. The important thing is can study. This study again, it's there. So that means this class also redefines study. So the function is going to be called study. It returns nothing, void. Apply, and then go back to my question paper. So both student and staff can study in their own ways. We did that. Basically, they meant redefine it. So I'm done with these two classes. That's pretty much it. That's all you have to put. So it shouldn't take you a lot of time. It's taking me a lot of time because I was explaining. Then I'm going to choose the generalization symbol, put it there. Basically, this means this one inherits from this. Basically, person would be my ancestor or my parent. Okay, ancestor is a bit far-fetched. So this would be my parent, right? So these are the children, student and staff. Its parent is the person class. Then obviously there's always composition or aggregation. They want to test you everything. So a university, see, it's written in it's not written in bold, and it's a capital letter. So I know this is going to be my class name. So I need to create a new class and then scroll this side a bit, put it there, and then it's going to be university. Let's see if we have any attributes. It has an alphanumeric name, right? This is, I don't know why they try to confuse you. Alphanumeric, right? It means that is, separate this word, right? Let's look, let me teach you the trick on how to understand any word. Especially if you're looking for a definition for a word, you don't necessarily have to. You can split it into two. Numeric. So I can divide alpha and numeric. So alphabet, right? Numeric, meaning that there's a number. So basically, alphanumeric means that it has both alphabets and numbers. What can we use to represent that? A string, obviously. Because if I say use an integer, can I represent characters with an integer? Nope. Technically, yes, but then that's not the point. You can't represent characters with an integer. Technically, for those geeks out there who don't really understand under the hood, like encoding ASCII code, I'm not talking about that. I'm talking about it in simple terms. So a string is a better approach, is the only answer here because you can have string of codes here and have numbers like this and letters too. So it's alphanumeric. It is alphabets and numbers. So that means it's going to be of type string. So it's called the name. So it's going to be in underscore name, which is going to be of type string, and then I'm going to make it private and then apply. And then go back to my question and a vector of person who study to generate research for the university, a vector of person class. As you can see, so this will be persons, right? And then it's a vector of person, basically the name of my class, my abstract, my not my abstract, my base class, private, and then apply, and then go back. When the university is asked to generate a research, they delegate the task to the person instances who study. So they delegate their task to, okay, this is the sick test. This was hard for people who don't really understand. So even though they told us every information that we need for the person class, there's still more information that's missing. So we need to be able to generate research. So I'm going to call my method generate research. That's it, to make my thing simple. Remember, when it comes to delegation, right, it delegates it to the person instances who study. You need to take in as a parameter the person who you are the thing you're delegating it to, right? But then, okay, for here, yeah, this here is okay. Yeah, I actually have to do it. I didn't want to do it, but then I have to do it. Remember, I need to delegate to my person class. That means the person class needs to also have the generate research. They're indirectly telling you that here. So I'm gonna click here and go to my operations and create a new operation, generate research, right? And then void because they didn't tell you what should return. Since they didn't tell you, obviously that means it doesn't return anything. And then I'm gonna copy this name, apply. So it generates a research, it delegates. Remember, I'm gonna use this vector to delegate, right? I don't have to take a parameter in there. I'll use this vector of persons here to delegate. And then I'm gonna click OK. Now I go back to my person class and add that operation to match there because if I'm delegating to my person class, it needs to find that method, right? What delegation means, it means that I am not going to be responsible for doing this. I'll let someone do the work for me. So it's like, I know it's a weird example, but it's like a father who runs away from his kids, from his responsibilities. Like I'm calling it quits. I'm not going to be responsible. Deuces, I'm out. And then he's gonna run away, not take responsibility, right? That's in essence what delegation is doing. It's like you don't want to implement it. You call someone who will implement that. So obviously, since you're calling someone, right? Um, okay, okay. I think I'm doing it. Let me think about it. Oh, okay. Okay, it's fine. Technically, it's fine because we have a vector, right? It's a bit tricky, this thing. It's gonna delegate, right, to generate research. Okay, it's fine. I'm on the right track. So it's gonna call generate research, and generate research will take in a university instance, right? It should take in a university instance because that's how. If you remember how we delegate, right? The class that's going to do the delegation, the class that is the objects, right? That is the composition. It takes the function without any parameters. Then the class we are delegating to, it takes an instance of that class, which is in this case going to be university. And we usually take it by reference. So I'm going to say university and then pass university by reference. We take it by address so that we save memory. it speeds up things. It makes the application faster. We take it by address or by instead of instead of taking it by value, right, or by the actual object, we take it by address. So this was a tricky part, the generate research part. Remember, they need to be in both sides because this is going to delegate to the implementation that that person has. So obviously, person needs to have the actual generate function. So there we go. We have our UML, and then that's pretty much it with the UML. Let's check. Let's look at the dependency between these two. Which one is part of which? This university is part of this person is part of this university. So therefore, the arrow will start from will come from my person class to the class that has me inside, right? So which class has person? It's the university class. So is it aggregation or composition? It's going to be aggregation because the university can exist on its own. The person, so it's not like the university gives you A, right? You don't need the existence of university in order for you to exist. So it's going to be aggregation. Keep that in mind. It's going to be aggregation. So that's pretty much it. That's the UML for this. You don't put any extra things that you're not supposed to put, right? So 2023 UML. So there's quite a lot of images here. So I'm also gonna put it inside mm, okay, let me just save it on the desktop. Then I can exit without saving and then I'm done. I don't know how long the session has been now because it's not even showing me the time anymore. But then I'm sure it's been around 1.5 hours somewhere there, plus or minus 1.5 hours. So let's continue. We're almost there. Question for C-style structures and function pointers, right? So C-style function structures and function pointers. The following, that's that practical that they had a lot of pointers. The pointer to self, right? That one. So this following example is a subset of code which makes use of C-style structures and function pointers to implement a triangle pseudo class or object. An extract of the code is shown below. Fill in the missing code. You do not, I repeat, you do not have to rewrite the code, only what is missing. So A, for example, A, what's missing is the string keyword. So let's see, we have our triangle.h file, and then we have the triangle, right? So the triangle, they didn't really explain, right? Yeah, but then you can scroll down to see more clearly, right? If you scroll down to see more clearly, you see that, oh, my pixels is actually a two-dimensional array. You see, it's actually a two-dimensional array of RGB. Is it RGB color? Yeah, I think it has to be RGB color. Yeah, of RGB color. The thing is, it's so hidden. It's hard to pick it up. So they gave the record structure there so that you can pick that up. So answer for A is going to be, wait, this is question what? Question 4, right? So this is going to be question 4, question 4, and then end of question 4. So A is going to be that, like I said, it's going to be that RGB color pointer. That's the only thing that's missing. So it's a two-dimensional array of RGB colors, the pixels, which makes sense because remember when we're dealing with pixels, it was an RGB color, right? And if you didn't understand it, there's also an example here, RGB color to set the color, right? One of the to pick to set the pixels. And then B, remember with the C star objects, right? Remember, record structure can only store data. So we created what is called function pointers. Basically, if an address to a function, right, it points to a function, to a function's implementation. So the syntax for doing this, you'd say void and then brackets, and then you dereference, you put a pointer next to the function name, then you put the parameters. So therefore, the only thing that's missing there is the dereference, or is that pointer. So for B, the answer is just the pointer. And then C, we are creating a triangle, right? So in order to create a triangle, remember, this is how you create a triangle. It's going to return that triangle, which is going to be a pointer. As you can see, it returns a pointer. OBJ triangle is a what? A pointer. So now I know, oh, so this function is going to return a pointer, but then what type of a pointer? I'm creating a triangle. So therefore, it's going to return a triangle pointer. So this will return a triangle pointer. And then D, for D, you want to destroy, right? Remember when you talked about when you talked about pointers, right? Allocating on the heap, blah blah blah. So remember, a pointer stores an address, right? It stores an address. So the box, imagine there's a box inside the stack, right? Because there's no new keyword here. So let's just assume it's on the stack. So imagine that there's a box that stores only pointers of triangles, right? Meaning that it stores addresses of triangles, right? So that means that box itself only stores what is pointers or addresses to triangles, right? So since it stores addresses of triangles, that box itself, it resides within a shelf which has its own address. So we need to go to where that box itself resides to make those permanent changes. Why do you need to go to the address? Because, for example, if you want to find your friend, right? How do you find them? You tell them to send you your address. Send me the location. Like Khalid once said, send me your location now. So you are saying, send me your address, where you at, send me your location, right? So we need to take it by address. If you want to destroy that pointer and everything within the pointer, we need to go to where that pointer itself is located. So D is going to be address. So I need to take its address of that pointer. So the answer is just going to be the ampersand. And then E is going to be this, let's see. So you see, this will be the paint implementation, right? So this function pointer should point to this function. As you can see, it's exactly the same. It takes the exact same parameters. And then we're gonna have for each row. So we're going through all of the rows. So I'm gonna need to remember where with C-style objects, right? It's the same thing that we're doing in classes. It's just that with C-style objects, we sort of like do what are called pseudo object. It's like technically it's an object, but and technically it's not, right? It's not really an object. We're trying to mimic an object. So basically, it should work the same way we work with objects, right? But then remember, it's a pointer. In order for me to get the rows, right? If you remember the pointers video, in order for me to get the rows, I need to dereference and go to the actual object itself. So for E, there's two ways you can answer it. You can say dereference and then go to the object itself, right? To get the object itself. And then I put in brackets there so that it knows the pointer points to this object itself, this address. And then you can say dot int rows to get the rows. That's how you get it, right? That's the first approach. But then this is a problem because sometimes you might forget the bracket. Let's say you forget the brackets like this. You won't know whether the pointer points to this address or you mean the whole thing is the address. So by default, it'll assume that is the whole thing and get confused. Like, what do you mean this is an address? This makes no sense. So in order for us to avoid that error of possibly forgetting brackets, right? There's a better syntax. So that's why I'm going to write two answers here. It could be this or this one. You can say obj self with that arrow like this. This is equivalent to using this. Oh, okay, I'm not done. I need to put the dot there. If you forget the dot, you lose marks because remember they didn't put the dot. Remember they say only put the things that are missing. So in full, it's like this, right? In full, it's like that. So I already have int rows. So what is missing? It's everything up until the dot. So you see, I need to put that dot there. I just almost forgot. And then the other approach is like this, right? So what's missing since I already have intros? It's everything up until before intros, which is this that I've highlighted. So this would be the answer for that question. It's that or that. And then E, F, and then F, what is F? Oh, calculate the area, right? So the area of a triangle, what is the area of a triangle? I don't know. Oh, so it's the same. Okay. You see, it's the same answer for E. But then I know you're accessing, just that I was thinking about the answer. So it's so this E it applies to multiple places in your code. So it also applies here. So it's basically rows times columns. Is that actually the area? I don't know. Not that good at maths. So like I said, this should return a pointer, triangle pointer. This goes back to here, right? Triangle pointer. We've already answered that because it's C. And then now we have F. You can't answer F if you didn't know number one, which is this. What is its data type? F, you won't be able to answer it. So with F, we know that's a two-dimensional array. So we allocate the outermost pointer, and then we'll be left with RGB color pointer. Because in full, it should be like this, right? Remember, in full, it's like this. New RGB color, and then we remove one of the pointers, and then we allocate memory for that. So we start with the outermost, this one. Replace that, we allocate rows there, and then then we go through that first dimension that we've allocated, each of the single rows, then we allocate this pointer, the second one. So this is usually how we allocate, right? So let's check what is missing. They said only put what is missing. The keyword new is already there. This square brackets and the semicolon is already there. So I need to remove this up until the semicolon, and the new keyword is already there, so I must remove that. So the actual answer that they're looking for is this. And then E, F, G. So with G, let's see G. Oh yeah, G. So remember, after allocating that outermost dimension, I remember what I talked about. We need to go through each of the rows in the pixels array. So remember, they already used obj triangle. They dereference, right? They access the object. What I need to fill in is the missing code for the underscore pixels array. So the only thing that's missing there is going to be underscore pixels for each row R. If they had used a different variable, it depends on your loop, right? Here they used R. That's why I'm using R. They could have used K. Make sure you use the right thing. And then for H and I, right? We are now linking, if you did the practical, right? We are now linking, these are function pointers, right? Remember how pointers can be created. There's two ways to initialize pointers. You can allocate memory on the heap, on the heap, right? Or you can allocate it on the stack like int num. And then you initialize, remember this pointer is meant to store an address. So I need some variable to exist. Let's say it's equals to 10. So how would I initialize num using this variable? So the variables, the normal variables, right, they only store the value. So I need to get the address of that variable using the address of, or the ampersand, address of what? A. So therefore now my pointer points to whatever shelf A is stored in, or which drawer A is stored in. So it takes the address of A. Remember, as we are dealing with function pointers, so it needs to take an address of a function. So how do I find it? It's there, it's in the code. It's always the name of that function inside of record structure. And then they append or they put a suffix of imp or implementation. So what is the function called? It's called paint. So its equivalent function implementation function will be called paint implementation or paint imp. So there's the function name. I'm gonna copy it. And then I know this would, since it's a function pointer, I need to initialize the pointer. So this is going to be the address of paint implementation, address of a function. So and then address of implementation. And then I is the same thing, it's just a different function. As you can see, calculate area is also a function pointer. Remember, it's a function pointer, meaning it points to a function. So I need to find the function that has the implementation, which is this one, calculate area implementation. So I'm gonna copy that and then do the same thing, address of calculate area implementation. And then we are almost done. There's the last thing. So remember remember what I said. When you allocate memory on the uh, heap, right? We always set it to null pointer. This null pointer, that's what's missing. You can delete the memory, but then there can be the mistake of trying to use that drawer or that shelf. So we need to always make sure that you set it to null pointer. So we cut that connection, that link. So it just points to null pointer or just points to zero, to nothing basically. So that we can get a proper error. We don't want to just jam and not tell us what's the issue. It needs to tell us, oh, there was a segmentation fault error, meaning that I tried to access something that was set to null or something that does not exist. So this answer for J should be null pointer. It could be it could be two answers here, right? Null is also in this one. This null from C is the same as this null pointer. It's the same thing. So this could be one of the answers. So that's question 4. We are done with question 4. And then let's get to question 5. Then we'll be done with the question paper. End of question 5. Right, so A. So here's the last question, which is exactly the same thing, code. So we have a museum has an artifact instance, has an artifact instance. Remember what I said, it's composition if it manages its life cycle, and it's aggregation if it does not manage its life cycle. So what happens if it's composition? If it's composition, you create that object. Since you're managing its life cycle, right? If it's composition, where's the nodes for composition? Okay. So if it's composition, right? If it's this, right? It means that the object, you need to use a pointer so that you can allocate memory on the heap. Because remember, when you allocate memory on the heap, it returns an address to where that object is stored on the heap. So we need pointers for that. And then this one, aggregation, just know that you won't use any pointer. So no pointer. Because you're not allocating memory on the heap. You're allocating memory on the stack, which will be managed for you by the computer. Like I said, the stack is like your grandparents' place, where your granny or your grandfather will be doing the things for you, your chores. So here it says whose life cycle it manages. So we know we have a pointer. So this asset artifact is stored inside of this class as a pointer because it's supposed to be managed, and to which it delegates its discover operation. An extract of the code is shown below. Fill in the missing code. You do not have to rewrite the code or what is missing, e.g. A is equals to string. So you don't have to rewrite the code. Like I said, they just tell you to fill in what's missing. A, they already told us that this is a class. It's a museum class. They told you. So you don't have to wonder whether that's an enum or a struct. I know A is going to be class because that's how we define the class, right? So class is what's missing there. And then B, for B, let's look for the destructor before. Oh, okay. So you see the destructor is not shown here. We cannot see it. So obviously this means that this would be the destructor because we already have the constructor. We already have the museum. We already have the copy constructor. So this thing here would be the destructor because it has the same name as my class, but it's not a constructor because we already have constructors. So this would be a destructor. And I can't say it's the parameter, but no args constructor because it's already there. There's the no args. So it's not a constructor, but then there's the same name. What else is the same name, but it's not a no args constructor. That's a destructor. So what's missing here is the tilde operator, which is this thing here. I'm not sure about the spelling, but then I think it's like that's how it's called tilde. You don't have to write tilde, right? I'm just explaining it. So the actual answer is this. Remember, if you don't forget your English class, the brackets, what does it mean? What do brackets mean? It means more information. You're just expressing more information on whatever thing you're writing there. So you see, it goes back to understanding English. And then since we have this label here, what label could this be? And you see, I didn't talk about inheritance here. You see, there's no inheritance here. So we can't think of protected. Protected is out of the picture. They didn't say, oh, it inherits from this. No, they say it has a. So this is a has a relationship, composition or aggregation. So we don't have protected. So this can, if there's already public there, this can only be private. So C is going to be private. And then D is going to be, remember we talked about the pointers, right? It said it manages the artifact. That's why they put a D there so that you understand. You have to really understand. So therefore, what's missing is a pointer because if it's managing its life cycle, it must take in an artifact pointer or a pointer to an artifact. So therefore, what's missing is the pointer since the memory will be allocated on the heap. I am responsible for managing its memory. So therefore, I need to use the a storage mechanism that allows me to be responsible, which is the heap, which is like your parents' place. So we have artifact here, copy constructor. You know how copy constructors work, right? To copy a copy constructor, right, is you want to copy that same thing. What do I want to copy? I want to copy an artifact. Remember A, you've already answered it. I want to copy an artifact. So I'm going to go here and say, I want to copy an artifact, right? That's what I want to copy. But then remember, we always copy things by address to save memory, right? And to make the application faster. You will understand this better if you're doing game development or something of that nature. You realize that your games won't have any lag, right? It's called lagging if it's like slow. So your games won't have any lagging, right? If you use addresses and pointers, right? So I need to take it by address. But then remember, it's a copy constructor. I want the copy. I want to work with the copy, not the original. Remember, if you pass it by address, it actually goes to where it actually resides and can make permanent changes. It's like, for example, if I visit you at your house right now and go inside the fridge and you give me the address, I go to that address, I go bend the house. Won't that effect be permanent? It will, right? Yes, it will. But then if you give me a copy of that thing, maybe a smaller, maybe a toy house that's a copy of your house that looks exactly like your house. If I destroy that toy, will it destroy your original house? Nope. So therefore, I need to pass it by const to say, okay, it shouldn't be changed. Take it by address, right? Addresses we know they're very good, but then also take it by const. Const, remember, is a word derived from constant. So make it constant, and basically it's gonna force you to work with copies. Basically, think of it as still working with the copies, but then you're accessing it via address. So basically, since you're accessing via address, there's possibilities of making permanent changes. I can burn that person's house because I know their address if I'm envious of their house, or I can sneak in the house and steal things. So I put that const there to say, okay, make sure it remains the things that you're doing, they make sure the object remains in its constant state in the way you found it in. And then I'm gonna click go to F, and then yeah, man, I'm starting to feel pain in my throat now. Yeah, no. So we have a constant here. Usually, remember with constants, we typically make them static, right? So that the constants are shared with all the instances. So there's one copy. We don't waste memory. You see, memory is always important. Memory is like the very most important thing. So what's missing on F is static, meaning that it's going to be shared. Remember when I put brackets, Google the meaning of brackets in English. Brackets just means more information. It's actually static. That's the answer for that question. EFG. And then since we already have public and we already have protected, what else could we need? Which other label could we need? Private. Because that's the only ones that we know so far, right? There's also friend. We don't usually use friend. We use it in operator overloading. You see when you get to operator overloading. So C here would be private. Okay, would it be private? Yeah, it has to be private, but let's see. Oh yeah, because I'm thinking about it because if it's C, that means I already answered it. There is private. So we already answered C. So we can just keep it because this is already answered, but we could have come up with the answer. So now we get into constructor chaining, right? This is the artifact.cpp. Remember when you had something like this, we chain. How do you chain? You put a colon there to say, go to this function, to this constructor, copy and paste that code that's there, and replace the first parameter with this abstract, with this constant. Replace the second parameter with this constant. So what's missing here is a colon. So that's what's missing, a colon there. E, F, G, H, and then B, we already answered B, right? Which was the tilde, it's the tilde right there. We answered B, it's the tilde. And then E, we answered that, that's the copy constructor. So now we are left with H. What is H? So we're implementing the discover const. So this, I think this should be and it returns a string, right? So this should be a accessor. Let me go back to my header file. So discover, you see, it returns a string. Let's look at our strings. Do you have any strings here? I don't see the strings. I don't see SS. Yeah, I don't see it. I don't know what this SS mean. Maybe it just means some string. Let me see. No, it doesn't mean a string. Oh, so SS, if you remember in your practicals, so they're testing if you actually do your practicals too here. Remember, SS stands for string stream. We create a string stream first, and then we insert into the string stream, streams of strings, right? Like this. Then once we are done, we return that string stream converted. I don't know why they forgot to put the return keyword there, but then we don't have to put the return. So make sure you only put what's missing, right? Don't put return for I, you'll get it wrong. That's not what's missing there. So here H is going to be string stream. So H is going to be a string stream. And then I, remember after inserting into the string stream, we need to return the string stream converted to a string by calling the str function, which is parameterless, right? So there's already a dot there. So all that's left is the name of the function that needs to be called, which is the str function, right? Which means convert it to a string. And then J, so set the name. Okay, so J is just setting the name. So we need to look at the name inside of our class. It's called underscore str name. So I don't need to go up there. I can already see it here. So the answer for J is just setting this underscore str name to that str name because this is a mutator, right? So I'm gonna say my answer for J, and pay attention to something here. Pay very close attention. Come on. You see that there's no semicolon here. So it's actually empty. I need to provide everything, even the semicolon. So I'm gonna say underscore str name is equals to str name with the semicolon. And then scroll down. And then that's pretty much it. We've reached the end. So that's pretty much it. So yeah, that's pretty much all you had to do here. I'll upload the images, right? And everything and the answers. So thank you for watching. See you in the next tutorial.